Look up at the intersection of I-75 and I-94 in Detroit, and you'll see something that doesn't belong anymore. A massive 6-story concrete structure covered in graffiti, windows blown out, nature creeping through the cracks. For decades, this abandoned building has been the first thing people see when they drive into the city. It's become a symbol of everything that went wrong in Detroit. But this wasn't always a ruin. This was Fisher Body Plant 21. And at one time, it represented American manufacturing at its absolute peak. Built in 1919 on Paquette Avenue, this factory churned out automobile bodies for Cadillac, Buick, and just about every luxury car General Motors made. During World War II, it built fighter planes. In the 1950s and 60s, it built limousines for presidents and movie stars. Tens of thousands of workers walk through these doors every day, earning middle-class wages that let them buy homes, raise families, and live the American dream. The building itself was designed by some of the best industrial architects of the era, with massive windows that flooded the workspace with natural light and reinforced concrete strong enough to hold stamping presses that weighed thousands of pounds. This wasn't just a factory, it was a cathedral of American industry. But by 1984, the machines stopped. The workers went home and never came back. The plant sat empty for nearly 30 years, slowly falling apart while the world moved on. Today, Fisher Body Plant 21 is finally being redeveloped into apartments, which means we're running out of time to tell its story. This isn't just about one building or one company. It's about how America built the most powerful manufacturing economy the world had ever seen, and then watched it crumble. It's about the Fisher brothers, 7 sons of a carriage maker who bet everything on a new industry called automobiles. It's about Detroit, a city that rose higher and fell harder than almost any place in American history. And it's about what happens when the thing that made you successful becomes the thing that destroys you. This is the story of Fisher Body Plant 21, the rise, the fall, and what it all means. Chapter 1. The Fisher Brothers and the Birth of an Industry. If you grew up riding in American cars in the 50s, 60s, or 70s, you probably saw it every time you opened the door. A small metal plate on the door sill with a horse-drawn carriage and the words "Body by Fisher." Most people never thought twice about it. But that little badge told a story about 7 brothers from Ohio who saw an opportunity nobody else noticed and built one of the most important companies in automotive history. The Fisher family wasn't from money. Their father, Lawrence Fisher, built horse-drawn carriages in Sandusky, Ohio, back in the 1870s and 1880s. It was honest work, skilled work, but it wasn't glamorous. Lawrence and his wife Margaret had 11 kids, 7 boys and 4 girls. And like most working families back then, the boys learned the trade. They grew up in their dad's shop in Norwalk, Ohio, learning how to shape wood, work metal, and build something that would last. By the early 1900s, the oldest brothers, Fred and Charles, could see the writing on the wall. The carriage business was dying. This new thing called the automobile was taking over, and if they wanted a future, they needed to get into it. In 1904, Fred headed to Detroit, where their uncle Albert Fisher had already set up a wagon-making business called Standard Wagon Works. A year later, Charles followed. They both found work at a company called C.R. Wilson, which made carriage bodies, but was just starting to dabble in automobile bodies. And this is where everything clicked for them. Back then, cars were basically 2 separate things: the chassis with the engine and wheels, and the body where people sat. Most car companies built the chassis, but outsourced the bodies to specialty shops. And those bodies were expensive. They were still being built like carriages, one at a time, by hand. Skilled craftsmen would shape wood frames, cover them with metal panels, add leather upholstery, install glass windows. Every car body was a custom job, which meant it took forever and cost a fortune. Most early cars were open-top roadsters because closed bodies were just too pricey for regular people. Fred Fisher saw the problem immediately. He'd watched Henry Ford revolutionize car production with the assembly line, churning out Model Ts by the thousands. But the bodies? Still being built the old way, in small batches by hand. It was a bottleneck. If cars were ever going to be truly affordable for working people, somebody had to figure out how to mass-produce bodies the same way Ford was mass-producing chassis. In 1905, while still working at C.R. Wilson, Fred built something that would change everything. The Cadillac Osceola. Henry Leland, who founded Cadillac, wanted to see if it was even possible to build a fully enclosed car body that could handle the vibrations and stress of an automobile engine. See, carriage bodies were built light and flexible because horses moved smoothly, but car engines shook like hell, and those old carriage-style bodies would literally rattle themselves apart. Fred figured it out. He built the Osceola with reinforced wood framing and stronger metal panels. It worked, and more importantly, it proved that closed bodies weren't just for rich people's custom orders. They could be engineered, standardized, and eventually mass-produced. That was the insight that launched everything. On July 22, 1908, Fred and Charles Fisher, along with their uncle Albert, founded the Fisher Body Company with money borrowed from a businessman named Louis Mendelson. They started small, in a little shop, but they had a vision that nobody else in the industry seemed to grasp yet. They weren't trying to be custom coach builders for the wealthy. They wanted to industrialize the whole process, design bodies that could be built in pieces, standardize the parts, and crank them out like Ford was doing with engines. By 1910, they'd proven the concept. Fisher Body became the exclusive supplier of all closed bodies for Cadillac, Buick, Oldsmobile, and Oakland. Not some of the bodies, all of them. That's when the other 5 Fisher brothers came to Detroit and joined the company. William, Lawrence, Edward, Alfred, and Howard each brought different skills, but they all shared the same obsession with quality and efficiency that their parents had drilled into them. The timing was perfect. Americans were falling in love with cars, and they wanted cars they could drive in the rain, in the winter, in all weather. Open roadsters were fun in summer, but if you lived in Michigan or New York, you needed a roof over your head. Fisher Bodies made that possible at a price normal people could afford. By 1916, the company had grown so fast they had to reorganize as the Fisher Body Corporation. They were producing 370,000 car bodies a year for nearly 20 different automakers: Ford, Chevrolet, Studebaker, Packard, you name it. At the time, that made them the largest auto body manufacturer in the world. Think about that for a second. In just 8 years, 7 brothers from a small Ohio town went from building carriages by hand to running the biggest car body company on the planet. But here's what really set Fisher Body apart. They didn't just build bodies, they invented new ways to build them. They developed interchangeable wooden parts that didn't require hand fitting. They designed precision woodworking tools that could cut to tolerances nobody had achieved before. They were engineers and craftsmen at the same time, which was rare, and they figured out something crucial about branding. In a world where most people didn't know or care who made the body on their car, the Fisher brothers turned Body by Fisher into a mark of quality. It meant the car was well built, solid, safe. By the 1920s, that little coach logo on the door sill wasn't just decoration, it was a promise. What the Fisher brothers really did was this. They took car bodies from being a craft and turned them into an industry. They proved you could build quality at scale. They made the closed automobile affordable for millions of Americans who would never have been able to buy one otherwise. And in doing so, they didn't just build a company, they helped build modern America, a country where cars weren't luxuries, they were necessities, and almost everyone could afford one. Chapter 2. Why Detroit Became the Center. When the Fisher brothers decided to build their company in the early 1900s, they didn't just pick Detroit because they happened to be there. Detroit was, at that exact moment in history, the only place in America where their vision could actually work. To understand why, you need to understand what Detroit had that nowhere else did. First, geography. Detroit sits right in the middle of the Great Lakes system, which isn't just 5 big lakes. It's the largest freshwater transportation network in the world. Ships could sail from Duluth, Minnesota, all the way through the lakes to the Atlantic Ocean via the St. Lawrence River. And Detroit was positioned perfectly on that route, right on the Detroit River, between Lake Erie and Lake Huron. That mattered more than you might think. The Fisher brothers needed 2 things in massive quantities: iron and coal. The iron ore came from Minnesota's Mesabi Range and Michigan's Upper Peninsula, some of the richest iron deposits ever discovered. Huge freighters would load up with ore at Duluth and Marquette and sail it down the lakes. Coal came from Pennsylvania and West Virginia, hauled by rail to Great Lakes ports. Detroit was close enough to both that shipping costs were low. You could get a ton of iron ore delivered to Detroit cheaper than almost anywhere else in the country. And when you're building hundreds of thousands of car bodies a year, that matters. The steel mills knew it too. By the early 1900s, major steel operations had set up along the Detroit River. Places like the Detroit Iron and Steel Company on Zug Island, which built blast furnaces in 1902 that were reportedly the largest in the world at the time. Fisher Body didn't have to ship steel in from Pittsburgh. They could buy it locally, fresh out of the furnace, and start stamping it into body panels the same week. That kind of speed and cost advantage was huge. Then there were the railroads. Detroit had become a major rail hub in the 1850s and 60s when lines like the Michigan Central and the Grand Trunk connected the city to Chicago, New York, and everywhere in between. By the time the auto industry took off, Detroit had one of the densest railroad networks in the country. The area around Milwaukee Junction, where Ford built his Paquette Avenue plant in 1904, was literally named after the intersection of 2 major rail lines. Companies could ship finished cars and parts to dealers nationwide faster from Detroit than from almost any other city. But here's the thing. If it was just about geography and transportation, Cleveland or Chicago could have been Motor City. What really made Detroit special was the industrial ecosystem that was already there before cars even existed. In the late 1800s, Detroit was a manufacturing powerhouse. It was the stove capital of the world. The city had massive railroad car factories. Michigan Car Company employed thousands of workers building freight cars. There were shipbuilders on the Detroit River constructing Great Lakes freighters, companies making marine engines, boilers, metal castings, copper fittings, brass parts. All of that required the same skills you'd need to build cars: metalworking, precision machining, welding, assembly. When Henry Ford, Ransom Olds, and the Dodge brothers started building automobiles, they didn't have to import talent or build supply chains from scratch. The workers were already here. The machine shops were already here. Companies that had been making railroad car wheels and ship engines just pivoted to making engine parts and chassis components. Detroit Copper and Brass, which had been supplying parts for locomotives, became one of Ford's biggest suppliers of brass radiators and engine components. The city already knew how to do mass manufacturing. Then Ford changed everything. In 1908, he introduced the Model T at his Paquette Avenue plant. By 1913, he'd perfected the moving assembly line at the Highland Park plant. That turned car production from a craft into an industry. Ford wasn't just building cars, he was proving that you could build them by the millions if you organize production the right way. And every other automaker in America watched and learned. General Motors, founded by William Durant in 1908, set up its headquarters in Detroit. Packard moved from Ohio to Detroit in the early 1900s. Studebaker, Hudson, Chrysler, they all came to Detroit because that's where the action was, and they brought hundreds of supplier companies with them. By 1915, the city directory listed 48 automobile manufacturers and over 100 suppliers. many of them clustered in neighborhoods like Milwaukee Junction and Southwest Detroit. Fisher Body didn't just benefit from this ecosystem, they helped create it. They needed glass suppliers for windows, leather suppliers for upholstery, paint companies, hardware manufacturers. All of those businesses set up shop in or near Detroit to be close to their biggest customers. It became a self-reinforcing cycle. The more car companies came to Detroit, the more suppliers followed. The more suppliers there were, the easier it was for new car companies to start up. And the whole system got more efficient every year. Labor was another huge factor. Detroit was growing fast. The population went from 285,000 in 1900 to nearly 1 million by 1920. Immigrants were pouring in from Poland, Italy, Germany, Ireland, looking for factory work. Black Americans were migrating up from the South during the Great Migration, escaping sharecropping for industrial jobs that paid real wages. Ford famously paid $5 a day in 1914, which was double what most factory workers made anywhere else. That attracted the best workers from across the country. The Fisher brothers could hire skilled craftsmen who knew how to work with wood and metal, and they could hire them by the thousands. Then there's the practical stuff nobody thinks about. When your Fisher Body and your biggest customers are Cadillac, Buick, and Oldsmobile, all of which are based in Detroit, you want your factory close by. If there's a design change or a quality issue, an engineer from Cadillac can drive over to the Fisher plant in 20 minutes and work it out on the factory floor. If you're building bodies in Cleveland and shipping them to Detroit, that conversation takes 3 days and costs a fortune in telegraph fees. Being local meant faster communication, faster problem solving, and lower shipping costs for these huge, bulky car bodies that were expensive to transport. By the 1920s, Detroit wasn't just building cars. It was building the entire industrial system that made modern automobiles possible. The mines in Minnesota shipped ore to the steel mills on the Detroit River, which sold steel to the stamping plants, which sold body panels to Fisher Body, which sold finished car bodies to the assembly plants where they were bolted onto Ford and GM chassis, which then got shipped to dealers on trains that ran through Detroit's rail yards. The whole thing worked like a machine, and Fisher Body was right in the middle of it, perfectly positioned to grow into the largest auto body manufacturer in the world. Detroit didn't just happen to be Motor City. It was built to be Motor City, piece by piece, starting decades before anyone had even heard of Henry Ford. Chapter 3. Engineering a factory for mass production. When Fisher Body built Plant 21 in 1919, they weren't just putting up another factory. They were engineering a machine, a building designed from the ground up to turn raw steel into finished automobile bodies as efficiently as humanly possible. And to do that, they turned to the most famous industrial architect in America, a German immigrant named Albert Kahn, who was revolutionizing what factories could be. Kahn understood something that most architects at the time didn't. A factory wasn't just a big shed where you stuck some machinery. It was a tool, and like any tool, its design determined how well it worked. If you designed it right, the building itself would make production faster, safer, and cheaper. Get it wrong, and you'd be fighting the space every single day. Fisher Body Plant 21 was 6 stories tall and covered over 1.3 million square feet. To put that in perspective, that's bigger than 20 football fields under one roof. The building stretched along Paquette Avenue with massive walls of windows, rows and rows of them, floor to ceiling, running the entire length of the structure. This was Kahn's signature move, what he called the daylight factory concept. Before Kahn, most factories were dark, grimy places lit by a few dim electric bulbs or gas lamps. Workers squinted in the shadows, which slowed them down and led to mistakes and injuries. Kahn flipped that on its head. He used reinforced concrete for the structure instead of wood, which meant he could build thinner walls and bigger windows without worrying about the building collapsing. The concrete could handle the weight of all the heavy machinery, those massive hydraulic stamping presses that weighed tens of thousands of pounds, while the huge windows flooded every floor with natural light. On a sunny day, workers inside Plant 21 could see what they were doing without straining their eyes. It sounds simple, but it was revolutionary. Better lighting meant better quality control, fewer accidents, and faster work. European architects would later look at photos of Kahn's factories and use them as inspiration for what became known as the International style. The clean, functional, glass and steel buildings you see everywhere today. But Kahn wasn't trying to make art, he was trying to make manufacturing work. The layout of the building followed a very specific logic. Raw materials came in on the ground floor via railroad siding that ran right up to the loading docks. Coils of sheet steel delivered fresh from the mills along the Detroit River would be unloaded directly into the stamping department. This was where the transformation began. The stamping floor was filled with enormous hydraulic presses, some of them capable of exerting thousands of tons of pressure. These machines would take flat sheets of steel and, in a single violent stroke, stamp them into three-dimensional shapes: fenders, hoods, door panels, roof sections. Each press had its own die, basically a massive steel mold custom-made for a specific part. You'd slide a flat piece of steel into the press, hit the button, and a second later it would come out shaped like a car door. It was loud, dangerous work, but it was incredibly efficient. What used to take a team of skilled metalworkers hours to hand shape could now be done in seconds by two workers operating a press. From stamping, the parts moved up to the welding floors. This is where Fisher Body's real expertise showed. In the early days, car bodies were assembled like furniture. Wood frames held together with screws and bolts, then covered with metal panels. Fisher Body pioneered all-steel construction, which meant welding hundreds of individual stamped panels together to create what they called a body in white, the bare metal shell of the car before paint or upholstery. The welding department used a technique called spot welding, where electrodes would clamp down on two overlapping pieces of steel and send a huge electrical current through them, melting the metal at that one spot and fusing the pieces together. A single car body might have 3,000 spot welds holding it together. In the early years, this was all done by hand. By the 1950s, some of it was automated, but either way, it required precision. If the welds weren't strong enough, the body would rattle apart on the road. Too strong. And you'd warp the metal. Fisher Body got really good at this. They developed what they called flash welding, which created continuous seams instead of individual spots. It was stronger, more weatherproof, and became an industry standard. After welding, the bodies moved up to the paint floors. This had to be on the upper levels because paint booths were massive fire hazards, and if something went wrong, you wanted the flames as far from the ground as possible. The bodies would go through a multi-step process. First, a chemical bath to clean and treat the metal so paint would stick, then primer coats to prevent rust, then color coats, then clear protective layers. Each step required drying time in ovens that baked the paint onto the metal. In the 1950s, Plant 21 installed what were then state-of-the-art downdraft spray booths with heat-sealed ovens that became the standard across the industry. The whole building was connected by a system of conveyors and massive freight elevators that could lift entire car bodies from one floor to the next. Raw steel came in at street level, got stamped into parts on the first floor, welded together on the second and third floors, painted on the fourth and fifth, and finished bodies came out on the sixth floor ready to be shipped to final assembly plants where they'd be mated with engines and chassis. The building itself enforced the workflow. Everything moved in one direction, upward through the floors, with gravity helping move parts along conveyors. There was no backtracking, no confusion. It was what modern engineers call continuous flow manufacturing, a concept that would later become central to lean production methods. But Fisher Body and Albert Kahn were doing it in 1919 before anyone had given it a name. The other genius of Kahn's design was flexibility. The open floor plans with minimal interior columns, thanks to those long-span steel trusses and reinforced concrete, meant you could rearrange equipment when production needs changed. Need to add a new stamping press? You could do it without tearing down walls. Need to reconfigure the welding line for a new model? The space was there. That flexibility kept Plant 21 relevant for decades, even as car designs and production methods evolved. What's easy to forget now is that this building was cutting-edge technology. The use of reinforced concrete, the scale of the windows, the integration of heavy machinery into a multi-story structure, none of this was standard practice. Kahn and his engineers were figuring it out as they went, collaborating closely with the Fisher brothers to understand exactly what the building needed to do, and then designing a structure that could do it. This wasn't architecture for architecture's sake. It was engineering in service of production. And it worked. Plant 21 and buildings like it became the template for industrial construction for the next 50 years. They proved that if you designed a factory intelligently, you could achieve levels of efficiency and output that seemed impossible with older buildings. The factory became a machine for making machines, and Albert Kahn was the engineer who made it possible. Chapter 4. The Product, Automotive Bodies as Industrial Art. If you stepped into a General Motors car anytime between the 1930s and the 1980s, the first thing you'd see was a small metal plate on the door sill. It showed a fancy horse-drawn carriage, a Napoleonic coach actually, and the words "Body by Fisher." Most people never gave it a second thought. But that little badge meant something. It was a promise that the car you were sitting in was built right. And for decades, Fisher Body delivered on that promise by turning sheet steel into some of the most recognizable automobiles in American history. So what exactly did Fisher Body make? The simple answer is car bodies. But that doesn't capture what they actually did. They took raw industrial materials, coils of cold-rolled steel, and transformed them into the part of the car you actually experienced. The seats you sat in, the roof over your head, the doors that closed with a solid thunk, the dashboard, the trunk. All of it came from Fisher Body plants. They didn't make engines or transmissions or wheels. They made the shell, the structure, the space where people lived while they drove. And in the early days of the automobile, that was revolutionary. Back in the early 1900s, most cars were open-air roadsters. You sat on a bench seat with nothing but a windshield between you and the weather. If it rained, you got wet. If it was cold, you froze. Closed bodies existed, but they were expensive custom jobs, hand-built like luxury carriages. A closed car could cost twice as much as an open one, which put them out of reach for regular people. The Fisher brothers changed that. They figured out how to mass-produce closed steel bodies at a price point that made sense for middle-class buyers. Instead of wood frames wrapped in fabric or leather like the old carriage builders used, Fisher Body pioneered all-steel construction. Steel was stronger, safer, and could be shaped by machines instead of craftsmen. That meant you could build thousands of identical bodies instead of one at a time. The process started with flat sheets of steel. These would get fed into massive hydraulic stamping presses that could exert thousands of tons of pressure. In a single stroke, the press would deform a flat piece of steel into a three-dimensional panel: a car door, a fender, a roof section, a hood. Each panel had its own custom die, basically a giant steel mold that gave the metal its shape. Once you had all the individual panels, they had to be joined together. That's where welding came in. Fisher Body became masters of spot welding, a technique where electrodes clamp down on two pieces of overlapping steel and send a massive electrical current through them. The metal melts at that exact spot, fusing the pieces together. A single car body might have thousands of these spot welds holding it together. By the 1930s, Fisher had developed what they called flash welding, which created continuous seams instead of individual spots. This made bodies stronger and more weatherproof, no gaps for water or air to leak through. After welding, the bodies went through painting. This wasn't just about making the car look good. The paint protected the steel from rust, which was a huge problem in the early days. Fisher Body used a multi-step process: chemical treatment to prepare the metal, primer coats to seal it, color coats for appearance, and clear coats for protection. By the 1950s, they developed sophisticated baking ovens that cured the paint onto the metal, making it incredibly durable. Different Fisher Body plants specialized in different types of bodies. Some made sedans, the everyday family cars. Others made coupes, which were sportier two-door models. Some plants built station wagons, which required special tooling because of their longer roof sections. There were plants that made nothing but truck cabs for GMC and Chevrolet trucks. And then there was Fleetwood, which Fisher Body purchased in 1925. Fleetwood specialized in luxury bodies for Cadillac, with higher-end materials and more hand-finishing work. But here's what made Fisher Body special. They didn't just build bodies to someone else's specifications. They were engineers and innovators. In 1933, they introduced what they called no-draft ventilation, a system of vents that let fresh air flow through the car without creating uncomfortable drafts. It sounds simple now, but it was a huge improvement in comfort and became standard across the industry. In 1935, Fisher developed the turret top, a one-piece stamped steel roof that eliminated the fabric or wood and metal roofs that were common before. This made cars quieter, safer, and more weatherproof. During World War II, Fisher Body plants stopped making car bodies entirely and switched to building B-24 bomber fuselages and M4 Sherman tank hulls. The same stamping and welding skills that made car bodies translated directly to military hardware. By the time the war ended in 1945, Fisher Body had produced over 21 million automobile bodies and countless pieces of military equipment. The quality was so consistent that Body by Fisher became more than just a supplier name. It was a brand in its own right. GM advertised it heavily. Magazine ads in the 1940s and 50s showed glamorous illustrations of Fisher-bodied cars with elegant couples and the Napoleonic coach logo front and center. The message was clear. If it has a body by Fisher, it's built to last. And for the most part, that was true. Fisher bodies were known for solid construction, tight panel gaps, doors that fit properly, and paint that held up over time. They weren't perfect. No mass-produced car is, but they set the standard. When you bought a Chevrolet or a Buick or a Cadillac, you knew the body came from Fisher, and that meant something. The car body itself accounted for about 30 to 40% of the total value of the vehicle. That might not sound like much, but think about what it represented. The body determined how the car looked, how safe it was in a crash, how comfortable it was to ride in, how well it kept out noise and weather. A great engine in a poorly built body made for a miserable car. A decent engine in a well-built Fisher body made for a car people actually wanted to drive. By the 1960s, Fisher Body was producing bodies for every GM division: Chevrolet, Pontiac, Oldsmobile, Buick, Cadillac, and GMC trucks, except for the Corvette, which had a fiberglass body and got a Body by Chevrolet tag. Every GM car had that little Napoleonic coach emblem on the door sill. It was ubiquitous. Walk through any American parking lot in 1965 and you'd see that coach everywhere. What Fisher Body really did was turn car bodies from craft into industry. They proved you could build quality at massive scale. They made the closed automobile, the car as we know it today, affordable for millions of people who could never have afforded a hand-built custom body. And they did it with precision, consistency, and a level of pride that showed in the product. That little badge on the door sill wasn't just decoration. It was a signature. Chapter 5. The Industrial System from Steel to Showroom. Fisher Body wasn't just a factory, it was the nerve center of an industrial system so vast and complex that it stretched from iron ore mines in Minnesota to car dealerships in California. Understanding how that system worked, how raw materials flowed in one end and finished car bodies came out the other, reveals something crucial about American manufacturing in the 20th century. It was all about control, coordination, and scale. The system started hundreds of miles away from Detroit, deep in the Mesabi Range of Minnesota, where giant open-pit mines pulled iron ore out of the earth by the ton. Freight trains would haul that ore to Duluth, where it got loaded onto massive Great Lakes freighters. Those ships would sail east through Lake Superior, down through the Sioux Locks, across Lake Huron, and down the Detroit River, where they'd unload at steel mills like U.S. Steel's plant on Zug Island or Bethlehem Steel's facilities along the waterfront. Those mills would take the iron ore, combine it with coal from Pennsylvania and West Virginia, and smelt it into steel in blast furnaces that ran day and night. The steel would come out as big coils of cold-rolled sheet metal, flat, smooth, and ready to be stamped into car parts. Fisher Body bought massive quantities of this steel. We're talking trainloads. In the 1950s, a single Fisher Body plant could go through thousands of tons of steel every week. The steel would arrive by rail car directly to the plant's loading docks, where cranes would unload the coils and feed them into the stamping department. But steel was just the beginning. To build a complete car body, Fisher needed glass for the windows, paint for the finish, upholstery fabric for the seats, rubber for the weather stripping, chrome for the trim, and hundreds of other components. Each of those materials came from a different supplier. PPG Industries supplied the glass. DuPont and other chemical companies supplied the paint. Turnstedt Manufacturing, which was actually owned by GM, supplied interior hardware like door handles and window cranks. There were suppliers for everything: bolts, screws, hinges, light fixtures, wiring harnesses. The whole thing was a massive logistics operation. Fisher Body had to coordinate deliveries from hundreds of companies, making sure everything arrived at the right time. If the paint shipment was late, the whole production line would grind to a halt. If the glass didn't show up, you couldn't install windows. This was long before computers, so all of this coordination was done with paper, telephones, and telegraph. Purchasing agents would place orders weeks or months in advance, and logistics managers would track every shipment to make sure it arrived on schedule. In the 1940s and 50s, Fisher Body pioneered what they called coordinated delivery, which was an early version of what we now call just-in-time manufacturing. Instead of stockpiling huge inventories of parts, they worked with suppliers to deliver materials in sequence, right when they were needed. This reduced warehousing costs and kept production moving smoothly. It required incredible precision, but when it worked, it was beautiful. Once all the materials were on site, the production process itself was a carefully choreographed sequence. Raw steel came in at one end of the plant and went straight to the stamping department, where hydraulic presses turned flat sheets into three-dimensional panels. Those panels moved upward through the building to the welding floors, where they were spot welded together into a complete body shell, what the industry called a body in white, because it was bare metal not yet painted. From welding, the bodies went to the paint department. This was a multi-step chemical process that started with cleaning baths to remove any oil or residue from the metal, followed by primer coats to prevent rust, then color coats for appearance, and finally, clear protective coatings. Each step required baking the body in massive ovens to cure the paint onto the metal. By the 1960s, Fisher Body plants were using some of the most advanced painting systems in the world, with downdraft spray booths and heat-sealed ovens that produced incredibly durable finishes. After painting, the bodies moved to final assembly, where workers installed glass, upholstery, dashboard components, door panels, and all the interior trim. This was the most labor-intensive part of the process because it required precision handwork. You couldn't just stamp out a dashboard and bolt it in. Somebody had to carefully fit it, secure it, and make sure all the controls worked. At peak efficiency, a single Fisher body plant could produce anywhere from 500 to over 1,000 finished car bodies per day, depending on the size of the facility and the complexity of the models being built. The entire process, from raw steel to finished body, took about 2 to 3 days. That might not sound fast, but remember, this was a product that weighed hundreds of pounds, had thousands of individual parts, and had to meet strict quality standards. Once the bodies were finished, they had to get to GM's final assembly plants, where they'd be mated with engines, transmissions, and chassis. This is where Fisher Body's tight integration with General Motors really mattered. In 1919, GM bought a 60% stake in Fisher Body, and in 1926 they acquired the remaining 40%, making Fisher Body a wholly owned division of GM. This wasn't just a business deal. It was a strategic move to control the entire production chain. With Fisher Body inside the company, GM could coordinate design, engineering, and production in ways that would have been impossible with an outside supplier. When Chevrolet wanted to launch a new model, their engineers could work directly with Fisher Body engineers to design the body and set up the production lines. When Cadillac needed a custom body for a limited edition luxury car, Fisher Body's Fleetwood division could handle it without negotiating contracts or pricing. The whole system moved faster and more efficiently because everyone was working for the same company. Fisher Body supplied car bodies to every GM division: Chevrolet, Pontiac, Oldsmobile, Buick, Cadillac, and GMC trucks. That's a staggering variety of products, from basic family sedans to high-end luxury cars to heavy-duty truck cabs. Each division had its own design language, its own quality standards, its own customer base. Fisher Body had to be flexible enough to build all of them while maintaining consistency and efficiency. This is where vertical integration gave GM a huge advantage. With Fisher Body in-house, they could control quality at every step. If there was a problem with body fit or finish, GM didn't have to renegotiate a contract or threaten to switch suppliers. They could just send engineers to the Fisher plant to fix it. If they needed to ramp up production for a hot-selling model, Fisher could shift resources without worrying about profit margins on that particular contract. Everything was optimized for the good of the overall company, not for maximizing profit on individual transactions. There were also massive cost savings. Because Fisher Body was buying steel, paint, glass, and other materials in such huge quantities, they had enormous bargaining power with suppliers. They could negotiate better prices than a smaller independent bodybuilder ever could. And because they were shipping bodies directly to GM assembly plants, often located right next door or a few miles away, transportation costs were minimal. You didn't have to pay to ship a bulky car body across the country. It just rolled off the Fisher production line and onto a truck that drove it a few blocks to the Chevrolet or Buick assembly plant. The whole system was designed to eliminate waste, reduce costs, and maximize speed. It was vertical integration taken to its logical extreme. GM controlled the steel mills, the parts suppliers, the body plants, the engine factories, the assembly lines, and the dealer network. Every step of the process, from raw materials to the customer's driveway, was inside the company. And for decades, it worked brilliantly. Fisher Body was the central nervous system of that operation, the place where metal became product, where industrial inputs became consumer goods. It's hard to overstate how sophisticated this system was for its time. We're talking about coordinating thousands of suppliers, managing inventory for hundreds of different parts, maintaining quality standards across dozens of plants, and doing all of this without computers, without email, without any of the tools we take for granted today. It was done with paper, phones, and people who knew the system inside and out. And when it worked, which it did for most of the mid-20th century, it was the most efficient automotive production system in the world. Chapter 6. The Golden Age, Peak Production and Market Dominance. The years between 1945 and the mid-1960s are often called the Golden Age of American manufacturing. And if you wanted to see that Golden Age in action, you looked at Fisher Body. This was when the company reached its peak, when Fisher Body plants employed over 100,000 workers, when nearly every General Motors car rolling off assembly lines across America had that little Napoleonic coach emblem on the door sill, and when working in a Fisher Body plant meant you had a shot at the American dream. When World War II ended in 1945, America had pent-up demand like nothing the country had ever seen. Millions of soldiers came home, got married, started families, and needed cars. During the war, civilian car production had been completely shut down. Every factory was building tanks, planes, and military equipment. By 1945, the cars on American roads were old, worn out, and falling apart. People were desperate for new vehicles. The numbers tell the story. In 1945, there were about 26 million cars registered in the United States. By 1960, that number had jumped to 74 million. America was building highways, suburbs were exploding, and the car wasn't a luxury anymore. It was a necessity. If you wanted to get to work, take the kids to school, or go shopping, you needed a car. And General Motors, with Fisher Body building the bodies, was perfectly positioned to meet that demand. At its peak in the 1950s, GM controlled nearly half of the entire American car market. In some years, it hit 50% or more. That meant 1 out of every 2 new cars sold in America was a GM product: a Chevrolet, a Pontiac, an Oldsmobile, a Buick, or a Cadillac. And except for the Corvette, which had a fiberglass body, every single one of them was built by Fisher Body. Fisher Body had more than 40 plants spread across the country by the late 1950s. These weren't small operations. Plants like the one on Paquette Avenue in Detroit, the Fleetwood plant on Fort Street, and facilities in Flint, Cleveland, and other cities employed thousands of workers each. Production numbers were staggering. In a good year, a single large Fisher Body plant could produce over 1,000 car bodies per day. Multiply that across dozens of plants, and you're talking about millions of bodies per year. Fisher Body wasn't just a supplier anymore. It was the backbone of GM's entire production system. The company also had enormous influence over automotive design. In the 1950s, American cars got bigger, flashier, and more dramatic. This was the era of tail fins, chrome, and two-tone paint jobs. GM design chief Harley Earl, inspired by fighter planes like the Lockheed P-38, introduced tail fins on the 1948 Cadillac. By the late 1950s, those fins had grown into wild, exaggerated shapes that made cars look like they could take off and fly. The 1959 Cadillac, with its enormous fins and bullet taillights, became an icon of the era. Fisher Body built all of those bodies, and their engineers had to figure out how to stamp, weld, and assemble these increasingly complex shapes. It was challenging work, but it kept Fisher at the cutting edge of automotive manufacturing. For the workers, this was a time of relative prosperity, though not without struggle. In 1950, the United Auto Workers Union negotiated what became known as the Treaty of Detroit with General Motors. The contract guaranteed regular wage increases, cost of living adjustments, pensions after 25 years, and company-paid health insurance. These were benefits most American workers could only dream about. A Fisher Body worker in the 1950s could make decent money, enough to buy a house, support a family, and maybe even own a car himself. The UAW was one of the most powerful unions in the country, and Fisher Body plants were heavily unionized. But the reality was more complicated than the myth. Auto work was volatile. Plants would run full speed during good years, with workers pulling overtime and earning solid paychecks. Then, demand would drop and thousands of workers would get laid off for weeks or months. Many Fisher body workers had to take second jobs, driving cabs, working construction, anything to make ends meet when the plant shut down. The work itself was tough. Stamping presses were loud and dangerous. Welding was hot, repetitive, and physically exhausting. Paint booths exposed workers to toxic fumes. The assembly line never stopped. Still, for many workers, it was the best option available. Immigrants from Poland, Italy, and Ireland, Black Americans who had migrated up from the South during the Great Migration, and white workers from Appalachia all found jobs at Fisher Body. The pay was better than farm work or service jobs, and if you stuck with it, you could build a career. There was also real pride in the work. These weren't just jobs, these were skilled trades. Workers could look at a Cadillac or a Buick driving down the street and say, "I built that." The phrase "body by Fisher" meant something. It represented quality, craftsmanship, and American industrial power. Fisher body plants were the economic backbone of cities like Detroit and Flint. When the plants were running, the whole community thrived. Local businesses, restaurants, bars, schools, they all depended on those Fisher body paychecks. When the plants shut down, even temporarily, the whole city felt it. By the mid-1960s, Fisher Body represented the peak of American industrial might. The company had proven that mass production and quality could coexist. They'd built millions of car bodies, pioneered new manufacturing techniques, and created good-paying jobs for hundreds of thousands of workers. If you wanted to understand American manufacturing in the 1950s, you looked at Fisher Body. But the world was changing, and the very things that made Fisher Body successful were about to become its greatest weaknesses. Chapter 7. The Structural Cracks, when the model began to fail. By the early 1970s, Fisher Body and General Motors seemed unbeatable. They controlled half the American car market, employed hundreds of thousands of workers, and their factories represented the pinnacle of industrial production. But the very things that made them successful were about to become their biggest problems. The world was changing, and the massive, vertically integrated system that Fisher Body had perfected was too rigid to change with it. The first crack appeared in 1973 when OPEC imposed an oil embargo that sent gas prices through the roof. Overnight, the big V8-powered sedans that Fisher Body specialized in became expensive to drive. Lines formed at gas stations. Americans who'd been happily driving Chevrolet Impalas and Buick LeSabres suddenly wanted small, fuel-efficient cars. And the only people making those were the Japanese. Honda, Toyota, and Datsun were selling every compact car they could ship to America. Then came the second oil shock in 1979 after the Iranian Revolution, and gas prices doubled again. By 1980, Japanese automakers had captured a fifth of the American market, and they were still growing. The problem was that Fisher Body wasn't built for that world. Their entire system was designed to produce large volumes of standardized products. When you've got massive stamping presses set up to make body panels for full-size sedans, you can't just flip a switch and start making compact cars. The dies alone, those giant steel molds, cost millions of dollars each and took months to manufacture. Retooling an entire plant for a different car model could take a year or more and cost a fortune. Every Fisher Body plant was optimized for long production runs of the same model. That's how you achieved efficiency. But when the market started demanding variety, small cars, mid-size cars, sporty cars, fuel-efficient cars, the system couldn't keep up. Meanwhile, Toyota and Honda had a completely different approach. Instead of building giant centralized factories like Fisher Body Plant 21, they used smaller, more flexible facilities. Instead of owning everything from steel mills to dealerships, they worked with networks of independent suppliers who could adapt quickly. And instead of the mass production methods GM had perfected in the 1950s, They developed something called the Toyota Production System: lean manufacturing, just-in-time delivery, and continuous improvement, or Kaizen. The philosophy was the opposite of everything Fisher Body believed in. Where Fisher Body stockpiled parts and ran production lines constantly to maximize throughput, Toyota only made what was needed when it was needed. Where Fisher Body had workers doing the same repetitive task all day, Toyota empowered workers to stop the line if they spotted a defect. Where Fisher Body viewed inventory as a safety buffer, Toyota saw it as waste that hid problems. And it worked better. By the early 1980s, studies showed that Japanese factories could build a car with half the labor hours, half the defects, and a fraction of the inventory that American plants required. A Honda Accord had better build quality than a Chevy Malibu, and it cost less to produce. The second structural problem was Fisher Body's massive fixed costs. Those enormous 6-story factories, the heavy stamping presses, the paint ovens, the thousands of unionized workers, all of it required high production volumes to make economic sense. When demand was strong and plants were running at 90% capacity, the numbers worked. But when sales dropped, the whole system fell apart because the costs didn't go away. You still had to maintain the building. You still had mortgage payments on equipment, and union contracts made layoffs complicated and expensive. Workers had seniority rights, supplemental unemployment benefits, and pension obligations that didn't disappear just because fewer people were buying cars. A Fisher Body plant either ran at near full capacity or it bled money. There was no middle ground. Toyota's smaller plants could adjust production up or down much more easily. Labor was becoming a crisis. By the late 1970s, UAW contracts guaranteed wages and benefits that made Fisher Body workers some of the highest-paid manufacturing employees in America. That was great when times were good, but it meant labor costs at Detroit plants were dramatically higher than at non-union factories opening in the South. When Honda opened a plant in Marysville, Ohio in 1982, they paid decent wages but no UAW premium, and they used modern robotics for welding and painting. Nissan did the same in Smyrna, Tennessee. These new plants were clean, efficient, and built with the latest technology. Fisher Body plants, some of them 50 or 60 years old, were using equipment from the 1940s and 50s. Automated welding robots had been invented in the 1960s, but Fisher Body was slow to adopt them. The old plants weren't designed for automation, and retrofitting them was expensive. So while Japanese and European automakers were using robots to weld car bodies with precision and consistency, Fisher Body still had rows of workers doing it by hand. It was slower, more expensive, and less consistent. The culture was rigid too. Fisher Body had been doing things the same way for decades. There was an attitude of, we built this industry, we know what we're doing. But the world had moved on. The Japanese had embraced Kaizen, where every worker was constantly looking for ways to improve the process. At Fisher Body, the mindset was to follow the established procedure and don't ask questions. Management didn't want suggestions from the factory floor, and workers didn't offer them. Then there was GM's strategic blindness. The company's leadership still believed in bigger is better, even as the market was screaming for smaller, more fuel-efficient vehicles. GM kept designing large sedans and station wagons, while Honda was selling Civics and Accords as fast as they could make them. Fisher Body built what GM told them to build, and GM was building the wrong cars. By 1980, GM's market share had fallen below 40% for the first time in decades. The company posted massive losses. Plants started running at half capacity, then a quarter capacity, then shutting down for weeks at a time. Fisher Body workers who'd spent their entire careers at these plants were getting laid off, and many of them never came back. The company that had once been the backbone of American automotive manufacturing was now a liability. The very qualities that made Fisher Body dominant in the 1950s, scale, vertical integration, standardization, were exactly what made them vulnerable in the 1980s. The world wanted flexibility, quality, and efficiency. Fisher Body offered volume, consistency, and legacy systems that couldn't adapt fast enough, and the cracks that started in the 1970s were about to break wide open. Chapter 8. The End. GM's strategic decision to shut down. By 1981, when Roger Smith became CEO of General Motors, the company was in trouble. GM had just posted its first annual loss since the 1920s. Market share was falling. Japanese automakers were eating their lunch. Quality problems were everywhere, and Wall Street was screaming for change. Smith looked at the massive bureaucracy he'd inherited and decided it had to be torn apart and rebuilt. What he did next would fundamentally reshape GM and seal the fate of Fisher Body. In 1984, Smith launched what was supposed to be a revolutionary reorganization. For 60 years, GM had operated as a collection of semi-autonomous divisions: Chevrolet, Pontiac, Buick, Oldsmobile, Cadillac, each with its own engineering, marketing, and production teams. Fisher Body and GM Assembly were separate divisions that served all the car brands. Smith believed this structure was creating massive duplication and waste, so he blew it up. He combined all the divisions into two mega groups, CPC for small cars and BOC for large cars. And Fisher Body? It was dissolved as an independent division and absorbed into the new structure. The theory was that this would eliminate redundancy, streamline production, and save money. But the execution was a disaster. Overnight, relationships that had been built over decades were severed. Engineers who'd worked together for years were suddenly reporting to different bosses in different buildings. Product programs got delayed, coordination fell apart, and instead of reducing bureaucracy, the reorganization created more layers of management, more confusion, and higher costs. One GM executive later said the reorganization stopped the company in its tracks for 18 months. But the damage to Fisher Body ran deeper than organizational charts. For the first time, the body engineers who'd spent their careers perfecting stamping, welding, and assembly were scattered across different groups. That specialized knowledge, the expertise that had made Fisher Body the best in the world, started to disappear. Quality suffered. The homogenization that Roger Smith wanted led to something nobody wanted. All GM cars started looking the same. A Chevrolet, a Pontiac, and an Oldsmobile might have different badges, but underneath they were basically identical. Customers noticed, and they stopped caring which GM brand they bought. Worse, they started buying Hondas and Toyotas instead. The bigger problem was that GM's entire vertical integration strategy was becoming a liability. Owning everything from steel mills to body plants to assembly lines had worked great in the 1950s, when demand was predictable and variety was limited. But in the 1980s, the market wanted diversity, customization, and constant innovation. And GM's massive fixed infrastructure couldn't deliver that. Fisher Body plants were expensive to operate. The buildings were old, some of them built in the 1910s and 20s. The equipment was outdated. Modernizing them would cost billions. And even if you did modernize them, you still had the labor issue. UAW contracts meant Detroit workers were earning significantly more than workers at new plants in the South or Mexico. By the late 1980s, GM was opening new facilities in places like Arlington, Texas, and Ramos Arizpe, Mexico. These plants were modern, automated, non-union, and located closer to growing markets. It made no economic sense to keep running old Fisher Body plants in Detroit when you could build bodies cheaper and better elsewhere. The closures started in the early 1980s. In 1982, GM announced that Fisher Body plants 21, 40, and 41 in Detroit would shut down. These were some of the oldest facilities in the system. Plant 21 on Paquette Avenue, the six-story Albert Kahn building that had once been a showpiece of industrial design, was producing only about one Cadillac limousine per 8-hour shift by the early 1980s. It was hopelessly inefficient. One plant engineer at the time said it was one of the most inelegant plants in the world, building one of the most elegant cars in the world. The math didn't work. Production from those plants was moved to newer facilities in Flint and elsewhere. 900 hourly workers and 300 salaried employees lost their jobs. Fisher Body Plant 21 closed for good in 1984. A paint company called Carter Color Coat bought the building in 1990, went bankrupt in 1992, and abandoned it. The building sat empty for the next 30 years. The Fleetwood plant on Fort Street in Detroit, which had built luxury Cadillac bodies since the 1920s, closed in 1987. 4,500 workers were laid off. Production moved to Arlington, Texas. One Fisher Body plant after another shut down through the 1990s and early 2000s. By 2005, most of the historic Fisher Body facilities were gone. Some were demolished. Others, like Plant 21, were left to rot. The few that survived were repurposed or absorbed into other operations. This wasn't about General Motors betraying Detroit or abandoning loyal workers, though it felt that way to the people losing their jobs. It was about economic reality. The business model that Fisher Body was built on, massive centralized production, vertical integration, high fixed costs, no longer worked in a globalized economy where flexibility, speed, and cost mattered more than scale. Keeping those plants open would have meant bleeding money. Closing them gave GM a chance to compete. In 2009, the story came full circle. General Motors filed for Chapter 11 bankruptcy. The company that had once controlled half the American car market, that had built the largest automotive body manufacturing operation in history, was broke. Fisher Body, as a brand, had already disappeared years earlier. GM quietly retired the Body by Fisher badge in the 1990s, and the plants that had employed hundreds of thousands of workers were either demolished or standing empty. Detroit itself was on the brink of collapse. The city's population, which had peaked at 1.8 million in 1950, had fallen below 700,000. Entire neighborhoods were abandoned. The tax base had evaporated, and Fisher Body Plant 21, sitting at the junction of I-75 and I-94, became a symbol of everything that had gone wrong. A massive concrete monument to an industry that no longer existed and a city that couldn't figure out what came next. The end of Fisher Body wasn't a single decision. It was a slow unraveling, driven by forces bigger than any one CEO or company. The world had changed, and the model that made Fisher Body great couldn't change with it. Chapter 9. After the machines stop, abandonment and decay. After the machines stopped, the Fisher Body plant did not collapse in a single dramatic moment. Instead, it entered a long, quiet phase of abandonment that stretched through the 2000s and well into the 2010s. The shutdown was followed by a systematic stripping of value. Industrial equipment was disconnected, removed, and sold off as scrap, leaving behind empty production floors where entire body lines once stood. Windows were shattered by time and neglect, roofs began to fail, and rainwater pooled across cracked concrete. With no maintenance and no purpose, the building slowly surrendered to the environment around it. Vegetation pushed through loading docks and factory floors, vines crept up brick walls, and trees rooted themselves inside what had once been tightly controlled industrial space. As security disappeared, the site attracted graffiti artists, urban explorers, and metal scrappers, each leaving visible marks of intrusion. Over time, the Fisher Body plant became one of the most photographed industrial ruins in America. Images of rusted conveyors, collapsed ceilings, and sunlight cutting through broken walls circulated globally, turning the complex into an icon of so-called ruin porn. Photographers and filmmakers traveled to Detroit specifically to document these remnants. framing the plant as visual proof of urban decay. This attention sparked controversy. Some argued these images preserved an important historical record, while others criticized them for aestheticizing decline and reducing an entire industrial landscape to spectacle. Beyond the factory walls, the surrounding area absorbed the consequences of abandonment. Large-scale job losses destabilized the local economy. Property values collapsed, and empty buildings multiplied across nearby blocks. As population density fell, crime and drug activity increased, accelerating what many described as the hollowing out of Detroit's industrial neighborhoods. The abandoned plant stood not as an isolated ruin, but as part of a wider urban vacuum. Over time, city and state authorities faced growing pressure to address the physical danger and economic burden of these massive structures. Demolition emerged as the most common response. Several Fisher body plants across Detroit were dismantled, including Plant 21 in 2009 and Plant 23 in 2018, each requiring millions of dollars to remove safely. The costs were immense, often estimated between $5 and $10 million per site, and sparked further debate. Some advocated preservation, arguing the buildings could serve as historic landmarks or anchors for redevelopment. Others saw demolition as the only viable path forward, clearing space for future use rather than preserving symbols of decline. A small number of former Fisher body facilities were repurposed into lofts, offices, or creative spaces, demonstrating limited possibilities for adaptive reuse. Yet most structures followed a different fate, years of abandonment, followed by erasure. What remained were before and after contrasts that defined the site's legacy during this period. Images of immense industrial order replaced by silence, fragmentation, and decay. Chapter 10. What Fisher body represents. Lessons from industrial rise and fall. Throughout much of the 20th century, the Fisher body plant stood as a powerful symbol of American industrial dominance. It belonged to an era when the United States was widely described as the arsenal of democracy, a nation whose strength rested on its unmatched ability to manufacture at scale. Factories like Fisher body were not simply industrial facilities, they were physical expressions of national confidence. The plant represented a system capable of transforming raw materials into standardized products, with a speed and volume no other country could rival at the time. In the decades when General Motors defined global automotive production, Fisher body played a central role in that dominance. The popular phrase, "What's good for GM is good for America," captured the prevailing belief that industrial success and national prosperity were inseparable. Fisher body, as a core component of GM's production machine, became part of that collective identity, a reminder that American power was built not only through innovation, but through the disciplined repetition of industrial processes on an unprecedented scale. At the same time, Fisher body offers a lasting lesson in the strengths and limits of vertical integration. By bringing body production inside the corporate structure, the system reduced uncertainty, improved coordination, and eliminated many transaction costs that once slowed production. Control over design, materials, and scheduling allowed for efficiency that helped define the modern assembly line economy. Yet that same integration also introduced rigidity. Large centralized plants demanded constant high-volume output to remain viable. Fixed costs accumulated and flexibility diminished. As market conditions shifted, the system struggled to adapt quickly. Fisher body demonstrates a fundamental reality of industrial organization. A model that is optimal under one set of conditions can become a liability under another. No structure, no matter how successful, remains permanently efficient in a changing economic environment. The plant also reflects the dangers of overspecialization at the urban scale. Detroit's growth was built almost entirely around the automobile. For decades, that focus appeared rational, even inevitable. The city aligned its infrastructure, land use, and economic identity with a single industry that seemed endlessly expandable. But when that industry contracted, the consequences spread far beyond factory gates. The collapse was not confined to production capacity. It extended to housing markets, municipal finances, and long-term population stability. In contrast, cities that diversified earlier, those with strong technology, finance, education, or healthcare sectors, proved more resilient. Fisher Body thus serves as a cautionary example of what happens when an urban economy places all of its weight on one industrial pillar, assuming that scale alone guarantees permanence. Globalization further reframes the meaning of Fisher Body in historical perspective. In the 1950s, the United States produced roughly 3/4 of the world's automobiles. By the early 21st century, that share had fallen below 10%. This shift was not the result of a single decision or failure, but the cumulative effect of global competition, cost differentials, and the international reorganization of production. Fisher Body stands as a clear illustration of deindustrialization in practice, the movement of manufacturing away from the places where it first achieved dominance. It also challenges nostalgic narratives that imagine a simple return to past industrial arrangements. The economic conditions that once sustained massive centralized plants no longer exist in the same form. History, as Fisher Body shows, does not move backward on command. Beyond economics, the legacy of Fisher Body is inseparable from its social impact. The decline of large-scale manufacturing eroded a broad base of middle-class employment that had once defined industrial America. Stable, long-term work tied to physical production gave way to a more fragmented and polarized labor market. Communities built around a single industrial identity found themselves exposed to sudden structural change. The plant's story underscores how deeply economic systems shape social outcomes and how vulnerable mono-industrial communities can be when those systems evolve. The consequences were not abstract. They reshaped patterns of wealth, security, and opportunity across entire regions. Architecturally and culturally, Fisher Body plants endure as industrial cathedrals, monuments to an age that believed scale itself was a form of progress. Their vast interiors, repetitive structures, and engineered precision reflected a worldview that valued order, efficiency, and permanence. As many of these buildings disappeared, a difficult question emerged. What should be preserved? And what should be cleared away? Preservation risks freezing decline into memory. Demolition risks erasing it entirely. The debate surrounding these structures is not simply about buildings, but about how societies choose to remember industrial power while making space for future development. In the end, the Fisher Body plant represents far more than a single factory or corporation. It functions as a mirror, reflecting both the extraordinary strengths and the inherent limits of the American industrial model. It encapsulates the rise and fall of Detroit, the transformation of global manufacturing, and the social costs embedded in economic progress. Fisher Body reminds us that industrial systems create prosperity, but they also impose long-term consequences. Its ruins and remnants do not simply mark an ending. They reveal the price of scale, specialization, and success in a global economy that never stands still.